Listen.
Hey everyone, Mark here again, and today I'm going to show you how to perform data engineering on Data Hub in CDP public cloud. I'm going to be using Spark today, specifically pyspark because I am still struggling to learn Scala. I've already put a dataset in S3 and granted my user access to the bucket. I did this by making sure the group my user belongs to was mapped to a role with access to the bucket using ID Broker. First, you're going to want to create a data engineering cluster. You'll do that by clicking Create Data Hub on the top right. Then you'll select the data engineering template. In my case, it's for AWS, but there will be a similar template for Azure if that's your public cloud vendor. You can see all the services that will be created. Today I'm going to be using Spark, Livy, and Zeppelin. I'll explain how these all connect later for those of you that are new to this. Before we continue, let me show you the hardware tab. Here, you can configure this cluster to optimize it for your workload. Okay, enough of that, let's go to the data engineering cluster now. You may have noticed that I already created a data engineering cluster. It's like we're on a baking show, I've already pre-baked the cluster. Let's go to Zeppelin and open up my S3 demo notebook. Here you can see my simple pyspark job. My dataset is a bunch of Amazon product reviews. Let's say I want to prepare this data to see if there's a correlation between the number of words in the review and the helpfulness score. First, I load the data with the columns I care about. Then get a word count per row, making sure to carry along the helpfulness score. And last, save it back to S3. CDP takes care of all the authentication in the background, so I don't have to deal with that headache here. Okay, I promised to quickly explain how Zeppelin, Livy, and Spark are interacting. Apache Livy allows Spark jobs to be submitted from a machine that doesn't have the Spark client installed. The Spark command gets submitted via REST API to Livy. Livy then forwards the command to Spark, which takes care of the rest. That's an extremely oversimplified explanation, but I hope that explains why Livy is in the mix here. Alright, back to Spark. How about if I want to run a Spark job on Hive data? Well, the data warehouse experience is using the same Hive metastore in the backend, so that won't be a problem. Only caveat, for now I can only access the data in the default database catalog. Before we go back to Spark, let me show you the data in the data warehouse experience. If you've been following along with our videos, you may remember this fake dataset I generated for the first attribute-based access control video. Let's access that same data with Spark now. I already have a notebook with my Hive data engineering demo. Notice that I didn't have to set up anything to read from Hive. The Hive configurations are already on this cluster, so you don't have to worry about copying Hive site.xml to every node. I really don't miss doing that. In this example, I'm going to see how many bids are being placed per hour to see how web traffic flows throughout the day. Using the Spark SQL context, I can write my SQL query to pull data in. Then I do some windowing to count how many bids happen per hour. Scrolling down to the results, you can see that the web traffic is pretty even at all hours, and that's because the data is all fake. But it gets the point across. Now, I bet all of you have much more useful data engineering projects in mind, but I hope this gives you a good idea of where to start. So thanks for watching today. Let us know in the comments if there are any topics that you would like us to cover, and subscribe to be notified of our upcoming videos. Also, if you have any questions about CDP, make sure to check out the Cloudera Community. There's a link in the description to take you there. Until next time.